Who is joining as SKCD2D? May I have any response?
What?
SKCD2D. Who is this?
Sagar.
Kriplani, not you. I think someone else is there. SKCD2D.
हाँ उसका नाम सागर है.
हाँ.
उसका नाम सागर है ऐसे बोल रहा हूँ.
Oh, अच्छा अच्छा. Okay. Okay. अच्छा. Sagar. Yeah, fine. Yeah, carry on, please. 32. Okay. So, Palak, Sakshi, 32 bytes. The question was how many bytes are there in TCP header? Umang, everyone, Jenish, Sakshi, 32 bytes. Do you mean 32 bytes? 32 bytes. Are you sure? 32 bytes? Yes. It's 20 bytes. 32 bits. No, not 32 bits. 20 bytes. Yeah, 20 bytes. Let me again remind you that TCP header, because it is important for the continuous next part of this session. If I have a look at the header structure, it comprises of two parts. One is called the fixed part or compulsory or mandatory part. Second one is called the optional part, right? Okay, let me have a look at this header structure. Present my screen. Can you see my screen? I hope you can
Yes,
see my
sir.
screen, right? Okay, good. So let me check how many bytes are there, because it is important to remember the structure, header structure. Unless you know the header structure, it is difficult to follow the rest of the things that I am going to discuss today. Side. This is the header structure. You can see here 20 bytes is the size of the header here. Okay, 20 bytes. 20 bytes. This is 16 bits. This one is 16 bits. This is the first field, second field, third field, fourth, that way. And each of the this is called one word. It is of 32 bits. This is 32 bits. 32 bits multiplied by 1, 2, 3, 4, 5. 32 multiplied by 5. So actually it is 32 equals to 4 bytes. 4 bytes into 5, which is equals to 20 bytes. 20 bytes is called a fixed header. It has this many number of fields. And that we also have one more part here, which is called optional header. Optional header. This part is, it is optional. It can have 0 bytes, means no optional part, or it can go up to 40 bytes. So far, we have not discussed about the optional header, and if time permits, certainly we will discuss. But this 20 bytes fixed header part is essential to know, because it carries most of the essential and most of the mandatory information to be carried out during data transmission, right? And also, you know that the TCP protocol, it's it is a protocol which is used for connection oriented services. It also provides reliable transfer or reliability. It provides reliability through flow control, error control, and congestion control. And moreover, this TCP protocol, it ensures that if any data is transmitted to the destination, it ensures that this data transmitted is being accepted by the destination or received by the destination. Unless the data transmitted is not received by the destination, it will keep on sending the same data that way, right? That's why it is called reliable transmission. And total number of bytes in the TCP header is 20 bytes, and 1 2 3 4 5 6 7 8 9 10, and 10 number of different fields, 10 fields, right? And varying size, different size. And source port, destination port, these are used for identifying the end applications. Similarly, one very important part here are the flags. There are 6 flags used in the TCP header, and they plays a vital role in the data transmission, right? And in the next part of this today's session, we will see how these flags are used along with the fields available in the header structure in order to provide connection to the end system, right? Or between two different systems. That's what we are going to discuss. And let's have a look at the things that we want to discuss today, right? So here in this part of this session, what we wanted to explain, actually, the TCP, when performs the operation or when it transmits data, before transmission it performs certain operation, right? That operation is called, and also during transmission and at the end of the transmission, it performs special kind of operations, or it exchanges special information or messages. And based on these messages, TCP is divided into different sections, or the TCP transmission is categorized or differentiated as different stages. That's what we are going to discuss. And this is called the stages of or phases of TCP connection, right? So please remember that at the end of the session, you are supposed to answer a few questions. So just be attentive in the session. TCP is a reliable and connection-oriented protocol used in the transport layer. The operation of TCP is performed in 3 different stages. The first stage is called connection establishment. Second phase or second stage of the connection is called data transfer. And third stage of the transmission is called the connection termination. In this video, we will explore all the 3 different phases or stages of TCP connection in detail. The first stage of the connection is called connection establishment. In this phase, the source and the destination establishes one connection in order to transmit the data. Because of this connection establishment phase, the TCP is called connection oriented protocol. Suppose that the sender wanted to transfer this block of data to a receiver. The data here, some sample data is given here, hello world sample data. And 4000, 4008, 4016, these are addresses of different data. And we are assuming that each of the data block comprises of 64 bits of data, and this is equals to 8 bytes. The first location is addressed as 4000, second one is addressed as 4008, 4016, so on, so forth. Now the sender need to prepare one sync packet to inform the receiver about the transmission of the data, and subsequently it will request the receiver to prepare for data reception. So sender will prepare one segment. This segment is called the sync segment. In this segment, the sender will set the sync flag of the header to 1. It will put the sequence number as the address of the first byte, and with these two information, it will send the sync packet. On receipt of the sync packet by the receiver, it will now prepare for data reception. What it will do, it will reserve some buffer space, it will set window size. Suppose that the receiver is capable of accepting only 80 bytes of data at a time. After receiving 80 bytes of data, unless it is consumed part of the it consumes part of the data, it will not be able to receive more data. That's why this 80, it is inserted in the Windows field or window size field in the header. It sets the acknowledgement packet, acknowledgement bit set to 1, and it also puts the acknowledgement number as 4000. It means that receiver is now ready to accept the sequence number 4000, or it is ready to accept the segment with sequence number 4000. This sync packet, this acknowledgement packet in response to the sync packet will be communicated to the sender. Once sender receives this acknowledgement packet, it will understand that the receiver on the other side is ready to accept data. So it will go for the next page preparation. As a next phase of the preparation, the sender will set one sender window. Since as for the information available in the acknowledgement packet, this window size is given as 80. The window size is given as 80. So it will understand that the sender can send 80 bytes of data without waiting for acknowledgement or without interruption. That's why 80 bytes means 10 blocks of data in this direction, 10 starting from 4000 till 4072. This is already a total of 80 bytes of data. It can communicate continuously. After this is been received, this acknowledgement is received, and this sender window size prepared, this sync or connection establishment phase of TCP is over. Once the connection is established, the data transfer begins. In the data transfer phase, the sender prepares segment with data. By that time, the sender is setting up the window size, sender window size. It puts one pointer to the first byte to be transferred. Then it prepares the segment for data transmission. The segment comprises of the sequence number as the address of the first byte to be transferred. Then it puts the data in the data section. This is the part of data in the segment. And suppose it has decided to send only 16 bits of data in one time. So 16 bits of data, that means here this hello world, these two data, this data will be packed in the data part, and it will be communicated as segment 1. Immediately after completion of this segment, sending of this segment, it will send the next segment where the address here, because this part is already been transferred, however not acknowledged. That's why it will start the next segment with the address from 416 to 424, and these two data, sample data, will be packed in the data and will be communicated to the receiver in the segment. That way it will continue till the data in location 4064, 4064 to 4072, and this one will be changed to 4064, and it will complete the transmission of the last segment. Total 5 segments will be transmitted, segment number 5, and it will wait for acknowledgement from the receiver. Once acknowledgement arrives, it will continue transmitting data in the same way. And this process, data transmission or data transfer phase, completes as soon as it completes the transmission of all the data that is shown in the data here, data section, till 4FFF, all the data, if all the data is transferred to the destination, it indicates that data transmission is over. Every time the sender receives the acknowledgement, it forwards the sliding window little bit forward, and that's why it is called sliding window, because this window slides towards right of the available window or available sequence numbers. During data transmission phase, the sender also take care of the flow control, error control, and congestion control. These 3 things are most important for reliable data transmission, which is provided by TCP protocol. Once the data transmission is over, the next phase of TCP is connection teardown or closing of the connection. The third stage of TCP connection is connection closing or connection termination phase. In this phase, the sender, once the data is completed, it prepares one segment where the FIN bit is set to 1, then it communicates that segment to the receiver. Once receiver receives this FIN segment or segment with FIN bit set to 1, it prepares the connection termination. It removes all the buffer from its memory. It clears the buffer, which one was established to accept data from the sender. It also removes the window size and all other relevant information with the related to the connection, and then it closes the session and it terminates the TCP connection. Here, the connection establishment and connection termination both are initiated by the sender. Only the receiver responds to the sender's request or sender's segment. And we also assume here that the connection is one-way connection, where only the sender sends the data and receiver receives the data. We are not assuming the scenario where both sender and the receiver communicates data in both directions. That's why this connection, the example taken here, is a one-way connection. If two-way connections, we wanted to establish two-way connections, sync packet, which we have seen was initiated by the sender, will also be initiated by the receiver. Similarly, the connection teardown or connection closing phase also will be established or initiated by both sender and the receiver. Otherwise, all other things or all other details that we have discussed in the one-way connection system is also applicable for two-way connection system.